So today is a little bit of an intro to R as well as just how we get started with R. There are some things that can be really helpful. It can be really overwhelming. I'm going to put the link to the OSF page here in the chat just so that we all have it. There are some files in there that you can download that has the some scripts for today, as well as this PowerPoint in case there are some links, and then some data once we get to it. In case you, for folks in the room, if you could, on a scale of 1 to 10, just put in how familiar you are with R, with 1 being not at all, and 10 being I could probably run this too. Okay. All right. Then it looks like we've got someone who is very familiar with R. So I might skip through some of these things. But feel free to interrupt with any questions. We'll see if other folks want to join as well. But what are some things that you're looking to get out of this session, I guess, for the folks that are here?
Okay, sorry, Dustin. Hi, I am Daniel. I don't know if there's people in the lobby. There's only like you and I apparently like in the participant list. But well, I'm as I put in the chat, I'm like proficient with art in general, but I do like workshops and these kind of things. I am a carpentry instructor, and I wanted to see how you like how you teach this because I'm like very interested in gathering like different opinions, different ways of like let's say confronting the instruction in R and these kind of things. So that's why I was like interested.
Oh,
But
definitely.
yeah, so I'm happy to follow along as you go ahead and explain.
Okay.
Unless you want me to weigh in and discuss anything, then it's fine. There's more people now.
I do, yeah, yeah. I know there's a lot going on, so I thought I would just record and then folks can follow along later on. But I appreciate that. Um, I also do the same thing where it's like, let's just see how other folks are introducing these topics. So, um, yeah, we'll go ahead and I'll just kind of walk through some things, maybe go through things a little bit more quickly. Um, but like I said in the uh, chat, I put for the new person who joined in the chat, there is the OSF page where I've included a couple links and files. So here in the files section, um, I have a couple, the R Markdown that is a template that I'll use, as well as the PowerPoint and some data. So you can download this entire folder and you'll be all set for today. Um, I have a little guide here to install R if folks are still unfamiliar, but I will move forward on that one. Some of the things that when you're getting started with R that I really try to highlight is one, to really make this a reproducible workflow. So I want this to be able to, I know it can be really daunting to open this and then whenever you close it, you're like, did it save? What's going on? So really trying to walk through those steps to make sure that basically if your computer shuts down or explodes or whoever knows what happens, that you can get back to where you were just by running all of the material that you do have. So here are some pieces that I want to walk through just to get started because I don't feel like this is explicitly stated really anywhere. Um, the first part is what I call starting with a blank slate. So if we go and navigate to R, if we just open R up, which I will do now, uh, and I use R Studio. I haven't yet transitioned to using like Posit or anything else. Um, I just find R Studio just that's what I've used for a very long time, so I should just continue to use that. And my computer, of course, is going really slow because it's trying to do too much. Um, but anytime with the default settings, whenever you go to close R, it will ask if you want to save the workspace. And this is something that can be really confusing at first. And so I always uncheck that box and tell it to never save this data, uh, the R data file. That is because what it will do, what the R.R data file is, it will save basically a snapshot of everything that you've done. So even if you have made mistakes in your code or you've changed a variable or updated your data in R, it's going to save that. And this makes it less likely for you to reproduce where you were going. So I always will default to taking that out. So here in R, if we navigate up into tools, up in the top portion there, and we navigate down to global options, that will open up this dialog box, and then we are looking right here in this workspace section where we want to say we don't want it restored, and we don't want to save this on exit. I hit that to never. Um, the only times when I would likely change this is if I was working with a very large data set that would require a long time for it to load in, and I want to just make sure that that portion has been saved so that it doesn't cause any problems moving forward. But default to just never ever needing to save that data. And like I said before, feel free to interrupt with questions or comments. Like you can raise your hand or you can say something in the chat, whatever is helpful for you. These are just some other more personal preferences that I like to do. I want folks to feel like our studio is theirs, and that it is going to work for you. So one of the ways to do that is just how it looks. That is really helpful for me is like making it look uh, really nice or in some appearance that I like to have. So we're going to go to, again, navigate to that tools, global options, where we see this page again, and we are going to select appearance, um, or we are going to actually select code. I'm sorry, I got ahead of myself. Uh, and here we will select display. Um, I am just gonna, and one of the things that I like to do is just allow scrolling past the end of the document. It makes it feel more like a Word document or something where you'll scroll a little bit easier. Um, and then down here at the bottom, because we'll use a lot of parentheticals or just parentheses, it's nice to have what are called rainbow parentheses, where the beginning and end will be the same color. So then you'll start seeing that as you nest the parentheses, that they match in color, and it makes things a little bit easier to follow and navigate. Finally, I always encourage folks to change the appearance. So the default is very much a very bright and white background, and some folks really enjoy using that. Others, it's you want to have maybe some chaos, or you want to update the background just a little bit. So go ahead and navigate. You can figure out one that works best for you, You can even change the font size. Sometimes as I am teaching, I might need to zoom in just a little bit more. So if we update that, then the text becomes a little bit larger, easier to read when I'm projecting on a larger screen. Um, but that is a easy way to update those things. And then the code feels more like it's yours once you have this background or the things that you do like to use. Um, so we're going to go back here to our PowerPoint. That is the make it your own, make it look really nice. And then when I talk about using R, I usually like to talk about it as a you're creating a cookbook. You're creating these recipes on how to work with your data. And you need very explicit steps as you go. Um, this was, of course, an AI generated image where this was baking and cooking. I thought was a good way to go about it, but I like to think about it more in if folks have seen the Great British Baking Show, where this community is very inviting and open and helpful, and we're all working together to try to figure these things out. So when we are working with data, it's very much you have a recipe and you are laying things out. You start with here are the ingredients, which is your data and the libraries that you're going to use, and then you walk through all the steps on how to get to that final product. Um, so I will, let's see, on time, we'll spend a little bit of time here just getting familiar with what our studio looks like. So I'm going to try to keep this metaphor going with talking about it as a kitchen. And we just want to get familiar with what it looks like. So when you open R, as I had just previously, if you are opening it for the first time or you have closed things out previously, you'll see three main panes here. Um, and each of these have their own unique component. Uh, and as we code and we actually write the recipes, we'll start to see that there will be a fourth pane that emerges. So this is just a kind of walkthrough of what each of these panes and sections can look like. Um, so you can see in the top left, that's that new pane that I didn't yet have in this section. So this is where you are writing your recipe, where you are writing those steps, how you put things together, or folks will sometimes consider this their script. Um, we'll see the environment up in the top right, where that is where basically when you make something, when your recipe calls for something and you've created it, it will appear in the environment. The bottom right will be the viewer pane. This is where you can look at the files that you have, as well as where all of your graphs and figures will appear. And then the bottom left is the console. This is where the output tends to be, and what you can think of as the brain of R and R Studio. That's where all the processing happens. I do have some links here for folks. This is just, you can use it as a, like sometimes you can directly type into the console, or you can, not sometimes, you can always do that. And this is where you're just telling R what computations to have and do. This portion in the console will not be saved. So if you want to be saving your steps, you want to make sure that that is represented in the script. This just walks through some examples on how you can work with the creating something in the environment. Um, so if we were to want to create an object, we want to create something, like if we were talking about a class and we wanted to see how many students were in the class, we could create that object. And I'm going to navigate back over to our R Studio. And so R, you will type in the actual, the name of your variable, and then you want to do an assignment operator. And that is going to be seen by the left arrow and the dash. So it creates an arrow. And this is saying take whatever's on the right-hand side and put it into this object that I've created called class. And we're going to say that there are 20 students. You hit enter, and then you can see over in the top hand in the right column, there is a new value called class that has the number 20 in it. There are some keyboard shortcuts as well, which I'll try to go through as we're talking about it because we want to make this work for us. We want to make our studio make our lives a little bit easier instead of more complicated. So if I were to write that again, uh, I'm using a PC, so it is Alt minus, and that will just automatically create that assignment arrow. It should be, I believe, Command minus in for Macs. You can always check those out here by going to Tools and then looking at the keyboard shortcuts. You can use the keyboard shortcuts help, and it will show you all of the different keyboard shortcuts that are there. And if there are some that don't quite work for you, you can update and modify what the keystroke combination is. So that can be really helpful when you're trying to make things work for you and go a little bit quicker. So we can call objects, we can ask them to do things. So what we can do is, let's say that there are 4 less people in our class. So we can say class took away 4. So class minus 4, we hit enter, it will give us what that new number is. But what you'll notice is that our class variable, or our value up in the top right in the environment, did not change because we just asked for a simple subtraction from that variable, not to actually update or change that variable. The way then to do that is to keep our assignment operator. So we could say class gets or is assigned with that assignment operator. And then we say class minus 4. We hit enter. And this is where some folks feel a little bit more overwhelmed or just a challenge at first for working with R, is that it doesn't tell you things that you didn't ask for. So it is extremely smart, but it is also very stubborn. And that might be a good way to approach working with RStudio and R, because I didn't ask for what the product was, what the number was at the end. I just said, assign this, create this new variable, or update my variable. And then it's like, okay, I did it. Now what? But you didn't actually ask for it. We can see in the environment that it has changed, but down here, if we want to ask for it, we will just state that name again, and we can produce what the actual numeric value is. So as always, it is very smart, but also really stubborn in that it will only give you the minimum amount or whatever it is that you're asking for. We can then create some new variables. I'm going to walk through and skip over some of these just so I can get to some of the other portions of today. And one of the things that is always really helpful to remember is that you don't have to keep all this in your head. You don't have to remember every single specific component. That's what you start saving scripts. You start looking back and like, oh, I did this before. Here's how I did it. You start saving things. I have an R folder in my Firefox browser that is hundreds of pages, but they are all really helpful for me to go back to it. So it is okay to not remember these things Um, I don't remember all these things, and that's okay. So this is where that R .r data file comes in. So if I close RStudio, if I come back here and close it, I didn't ask, it's not saving my data file, so it's not going to prompt me for it. If I then go and try to open it again, I'm going to open RStudio up one more time. Now it just starts again. It starts fresh from the beginning. All of the work that we had is no longer there. Nothing in the environment, nothing in the console, um, because we didn't save our recipe. We just went into the kitchen and started messing things up. And my wife always gets upset when I just start adding things to recipes. Um, that's what this essentially is. You're just adding new ingredients, but you're not writing it down. You're not keeping track of what it looks like. So then we can't reproduce it. If anyone remembers Clippy from old Microsoft versions, here's a nice little suggestion. So maybe we should actually just not type everything into the console. We should be using some scripts. Um, Now, I know that there are folks that are more comfortable with just using a script versus a markdown document or a Quarto document, which now Quarto is taking over for our markdown in a way it's more versatile from my understanding, and you can do a whole lot more for it. So let's go ahead and we can let's open the if you're trying to follow along, let's open a new document. So I'm going to pull up RStudio again, and then I am going to go up here in the top left. Uh, it'll bring down this pull down document, and I'm going to open up each one of these just to show you what the differences are among them. But then I tend to start using these Quarto documents. But I want to just show what each of these are. You might be asked to, if you haven't updated or used R before, or used a Markdown document, you might need to update some things. But whenever you're opening a new like Quarto or our Markdown document, it'll ask you to label some of these things. These are just the titles of the document. This is not the title of the file, so this is just going to be um, just the title of that specific document, and then we'll keep all of the defaults for right now. I'll hit create. And then at the same time, I'm going to make an R Markdown document with the template file. And so walking through some of the differences here, the R script, which was that first one that we selected, will look like this. It is essentially just a text file. There is nothing fancy that goes along with it. It is really just anything that you write in this document is essentially a console, the saved version of your console. So you can walk through and we can start putting those same class 20, and then we say class gets class -4. And now we've saved, we would of course use our floppy disk to save the document. Um, but here are all of the steps that we would need for this particular recipe. And in order to run each of those, you can select here, there's a run section um, that will run the specific line that your cursor's on. Or I usually don't use scripts, so I am less familiar with all the other options. You can also, for my particular, you can use keyboard shortcuts again. For PCs, it's Control Enter. I believe it's Command Enter for Macs. But if you try that out and it doesn't work, let me know. Um, but that is, you can also highlight multiple lines and it will run them in sequential order. But this is, you have only R code in here and any sort of comments that you want to put. So if you would like to add a comment, which means that it is text that is not run as code, you will use the pound sign. Um, or if you're younger than me, hashtag, uh, and you'll be able to write in a note to let you know what it is. So this is more of a note or a comment, uh, so that you're aware maybe of the code. That could be one way of how to organize it. Like I said, sometimes folks enjoy this format, but we want to make our work for us. So let's use either a Quarto document or a R Markdown document. These will work very similarly. Um, the only reason why they're looking different is because this Quarto document is in the visual section for editing. If we navigate over to the Markdown document again and select visual, it will look very similar. So this was a new update for RStudio where now it looks more like a series of code, like a series of a Word document. And what is really nice about these Markdown documents or the Quarto documents is you are able to add text in conjunction with your code. And this is where you can start creating reports and you can actually, if we should have time to be able to do this, but actually run some models and then actually pull in the estimates or pull in any information from a model that you run right into the text so that anytime you update the model itself, it will also update the text. Um, so these are just some examples for folks who are just joining. I'll pop in the OSF link. Um, if you want to download, there's a PowerPoint as well as some data and some code. We're just walking through some distinctions here. Feel free to jump in with any questions. Like I've got the chat open. You can raise your hand or do whatever's most comfortable for you. But we're talking about these distinctions between code or a script file or a .r file and a Quarto document or a Markdown document. So you'll notice that for these differences, there is specific text that you can have, and then you have what are called code chunks. And this is then, as you can see here, the very complicated 1+1 or 2 times 2. Glad that we can use RStudio to figure those out. Uh, but that is where the specific code will be run. So anytime that you need to run R code, you would create one of these chunks, and then you can run either everything in that section by hitting this play button, or you can use those keyboard shortcuts that we had before, the Control Enter, or up here in the top, like middle-ish, you can have run and with different kinds of options of what you can run. If you want to run the whole chunk, if you want to just run a specific line, even if you want to run the entire document, you can do that. Or sometimes I'll use these sections here, these buttons that will run everything up until this specific code chunk. So that can be really helpful when you're needing to update and get back into something. So this is just going through kind of what that looks like. Again, just some reference points to help with navigating this if you want to go back to it. So we talked about some of these things. We talked about what the layout is of our kitchen. We talked about how to create recipes. They can be in notebooks, markdown files, scripts, really whatever is going to work. But what we also, so this is a point I know that there's a lot of information for some folks, so I wanted to check in, see if there were any initial questions or things that folks had at this point that they wanted to talk about while I get some coffee. All right, feel free to put anything in text in the chat if that would be helpful. I'll walk through some of these next steps a little bit more quickly so that we have enough time to actually work and code along. You watch me fail at coding or make mistakes, and then we can have some time at the end for some questions. So um, if you're new to R, you might have heard about different libraries or what a library or package is. I like to always quote Hadley Wickham here in talking about the package being like a book, a library is like a library, and then you check that package out from your library. So you will always need to install a package. That would be this collection of functions that you will then have on your machine. So you only need to install this once and always put it in the console. I don't like to save these in the script file or in our markdown files. Um, this only needs to happen once. So if we want to install the tidyverse, we would come back to our console and do install.packages. And then in quotes, we have to say what we want. I have updated this. I thought I updated it, but it will go ahead and pull all that information in. Now we have this on our machine so that we can then use it. This walks through some of the process, but making it more into the kitchen function that I've been using, that metaphor in getting a cookbook and then having that cookbook or recipe saved in your pantry or wherever you keep things. And then you're actually calling it so then you can use that function to work with it. Um, so let's transition into actually working in R. There are some other pieces here that I have, but let's just get rid of PowerPoint and we'll go right back into RStudio. So I'm going to open up the script that is saved that you should be able to access on the OSF. Um, I'm just going to come up here to restart R just so it's all clean and there's nothing saved in my environment. Um, so what I have here is just some additional pieces, but the same thing that you would download. We have our presentation. We have the Defense Against the Dark R's file, as well as a data folder. So those should be the things that you were able to download. I'm going to open up this RMD file, and let's navigate to the top. So this is just some information that you can refer back to when you want to kind of come back to this, but one of the things that why we also use Markdown documents is the ability to knit things together so that you can have this reproducible workflow and you can share all of your output and any information all in one package, especially for someone who is not familiar with using R. Um, so one of the things that you'll first want to make sure that you're doing, I do have quite a few libraries here that I like to use quite often. Um, if you're using the most up-to-date version of RStudio, there will be a bar up here at the top that will say, hey, you don't have these libraries. Do you want to install them? Go ahead and install them. Um, and you'll then be able to have this information. What we want to do then is to actually knit the document. So go ahead and take a second, and if you can knit um, to various formats, one of them being the HTML, which is a little bit easier, more versatile. What this is going to do is it is going to sequentially run all of our um, components. And let's see, I already made a mistake apparently. So I'm going to comment out. That means that that section will not run. Um, So I am going to save and reknit. Let's see how that will work. So like I said, it's going through, it's taking and merging together all of the text and code so that then it will output in your folder or wherever your working directory is, which we'll talk about in a second. It will give you a HTML file. This is what you can share with colleagues. And it has all the text as well as all of the output from our code. You can show the different functions or the calls, um, but I also like to highlight that these report functions, because it is whenever you're writing manuscripts, it is always helpful to have the cite packages so that you can provide credit to the functions that you've used. And this is a really easy way to do that within the EasyStats package. So it will give you every single library that you are using, that you've called already, and it will give you the citation as well as how it wants to be called in text. So that is a easy way or helpful way to do that, but we'll walk through each of these sections in a little bit more detail here in just a second. What I want to start off with is importing data. So this is often one of the most challenging places for folks who are new to R or working with R. Um, and I have found using the here function to be extremely helpful. Um, This is, you can either use the here function, or if you're working with lots of different scripts, creating a new package or a new project will be really beneficial. And what this does is it basically creates the boundaries around where you are looking. So instead of, if we uh, if we have our working directory, or you say set working directory just like this, um, that means it is only going to work on your specific machine. That is not going to be able to function anywhere else. So if you share your code, nobody else is going to be able to work with it. This is from Jenny Bryant, and I think I share an equal sentiment about how difficult or challenging this is whenever you have that set working directory in the beginning of a script, because then that means that I need to go and change whatever all of those paths are to get to the data for it to find out where it is. Um, and this comes from the RStats WTF section. So this is a nice resource for, here's all the things that they forgot to teach you about R. And I think these are really helpful, but again, just another resource that you can have. What I want us to focus on is this here function. This will, wherever you open your script from, and then you call here, that's where your working directory is. So it is setting and looking at just right here, wherever it was opened, that is where it's starting. So this is a relative file path instead of an absolute file path, so that whenever anybody opens it, it is going to look in reference to wherever it started. So if you have your file structure set up like this is where it's looking, is if I'm going to close R one more time, come back to our folder, open up the script file or the markdown file. And now when I take this library here function, again, control enter, it's going to say where it's looking. So now I know that it is starting, the starting point is in this specific folder, and then I can go from here into getting my data or looking at other scripts. And let's go ahead and import some data. So here I have a data set. I meant to delete that portion. This is using the Rio package, which is one that I just found recently. It's one that is what they call a Swiss Army knife for importing data, where you just need to use the function import rather than finding specific read.csv or txt or whatever data file or data type that you're using. This does use SPSS or can easily import SPSS files. It's basically a wrapper that pulls all of them together to make it a little bit more efficient. So we say import, and then we want to use the here function saying, look in the data folder and grab that specific data. So I am going to take all of these, run them, and then come down and run this function here to get our data. This is a Cards Against Humanity, that card game. They occasionally collect data from a lot of different folks in different areas to get just some random data. So this is really helpful for whenever you're teaching, say, undergrads or grad students about using R and you want to get some fun, interesting data. You can see in our data file, there's just a brief data dictionary that I've added. There's only a few variables, but some of the questions are around like level of education, race, how many of the Transformers movies have you seen? Do you believe in ghosts? Uh, or do you think it's acceptable or unacceptable to pee in the shower? So those are definitely some fun questions that really grab the attention of students. But we're able to set that up where now we have it able to pull in this data, and you should be able to run this whole entire thing just with this. Now, because it has a relative file path, you should be able to run this very easily, rather than needing to create something all on your own. I just have some template here about the steps that I usually take in having the specific section here in how we have all of our libraries here at the beginning, so that anytime that someone's using this, they will know exactly what needs to be used, and they can install those fairly easily. I then import the data. Depending on whether or not I need the variable names a little bit cleaner, I will use the janitor function. And another keyboard shortcut that I set is for our pipe function. I haven't quite transitioned to using the native pipe. Um, so I just use what's in dplyr, uh, and there's a clean names function that will, I mean, all the names are already clean, but it will create all lowercase and fill in any spaces and everything. So it makes it easier to work with some of the names. And then I have a section on wrangling data, anytime I need to visualize data, and then go into the statistical models. So for the remainder of our time, I want to focus on creating nice tables, as well as trying to report some in-text uh, data. So what we can do, I'm going to just keep this file open, um, or yeah, are there things that folks in the audience would really like to focus on, or should we just keep moving with what my plan was? Or are there any other questions? I know folks have come in and out, but if there's anything else that's pressing, I'd be happy to talk more about that. Okay. So in the visualization section, I'm going to create a new code chunk, which you can do up here with the +C button. And you can use R or other types of programs, but we're using R, or you can use Control-Alt-I to insert a new code chunk. What we will do is start with just a descriptive table. So this is going to capitalize on the psych package as well as sjplot. Sjplot I really like using. It does a nice job, and to make customizable tables a little bit easier to work with. So I tend to start with just naming the data. We're going to use the describe function from the psych package. And then in the sjplot package or library, we can pull that tab underscore data frame, and then it will allow you to just take that information, and it puts it right into an HTML file, or a HTML table. So when you knit the document, it's easy to pull that information in. So this is going to go, if we were just to call the describe function, it's pulling in all this information. It indicates when there are, uh, if there are factors, so then it wouldn't make sense to use. But here we have age, and let's see, we have our ID, income, gender, age, being a mean of 49. You can also then use different functions here at the beginning to pull in and only select certain variables. So if we only want then we can create our table. You can then update that a little bit more by using the tab underscore data frame. And if we take a look at sjplot here, we can see that there are lots of different ways and things that we can use to make these look a lot nicer. Um, I tend to just start with the looking at the table and being able to update that, where you can add titles and footnotes. So if we wanted to add a title here, we could do so very easily. Table 1. Where then we have that all that information all ready to go and easily interpretable, so that you can basically take this uh, and either screenshot it and put it in your manuscript, or even just copy paste it, and it will work very nicely in Word or Google Docs, things like that. There is also a nice, easy way to get some correlation tables. So if we only want to include, let's see, um, our age variable, let's just look at what the names are of this again. If we want age, books, so how many books they've read, and how many Transformers movies they've seen. And then we can get a correlation table from that that is in APA format that you can update and use. This will default to including the stars for significance levels, and then it will actually gray out any sort of non-significant relationship. So this can be really nice and helpful, where we can then include a title where we're going to say, this is table 2. And then you can, I'm going to just take a look back at our reference, and there is trying to find the tab core. There it is. You can specify what correlation method you want, whether or not you want it listwise or pairwise deleted. You can have it actually show the variable, the p-values, but this was what I was looking for, is the triangle. So oftentimes you don't need both sides. You can actually specify if you want upper or lower. And then we can see that we have our variables all set. I've even used it in the past where you can specify what the like the cross, if we're looking at age to age, we know that that would be a correlation of 1. You can specify and put the mean value with the standard deviation, so then you have a correlation table that has all the descriptives, which is can be useful sometimes. You can also update the variable names, which is the var labels. So if we come back here, we do var.labels. And I'm going to say number of books and number of Transformers movies. And then that will update, and you can have it look a lot nicer. You can then select different columns or update that however you want. You can change any of the subheadings. So this is one way to really get a nice table very easily that you can update. And if we go through and I hit knit again, this will take all of that information, rerun it. So this is again why you want to make sure that it's reproducible, so that all the steps can be run no matter what, in sequential order. So if we go back to our folder and I open this up, it will now include those tables that we created. Down here, there's that, our descriptive table as well as our correlation table. And then finally, what I thought would be helpful, we can look at some statistical models. So um, start with just a simple linear, or we'll do some linear regression, since that is fairly common in the social sciences. So let's just call it model one, and we will use the linear model function. And I'm going to take a look back at the names of our data files, where maybe we can see if we can predict income, how much income somebody has, see what is a significant predictor of that. So I will say, let's predict income by, let's include age, gender. Let's do if they believe in ghosts, or how many Transformers movies they've watched, and do they think it's acceptable to pee in the shower. I never thought that I would say those words in a workshop, but here we are. Then you specify what the data is that you're pulling from. We can run that. Oh, not shower power. That's interesting. So again, this goes back to R is very smart, but very stubborn. And I just said, run this linear model, give it this label, and it's like, okay, I did it. Now what? And there are different ways that you can get this information. The most common is using the summary call, where then it will output all of your statistical values down here in the bottom. But this isn't really helpful, again, for a manuscript. You then have to go through and transfer these to Excel or Word or Google Docs or whatever you're using. And sometimes there can be copy paste errors. Um, what you can use is tab_model from the sjplot function or library. And you specify the model. And then over on the right-hand side, it will actually give you those outputs. Um, so it will give you all of the information. It even gives you the R² values. This is also very helpful for other kinds of models as well, like multi-level models. You can use this tab_model function, and it will give you all the appropriate information. It does even specify when p-values are smaller, but you can also use if we go back to our sjplot function reference, I'm going to navigate back and come on up to this regression models. You can specify a whole lot of different things. So you can have it not show how many observations there are. You can include R² or not. But here is where we'll spend most of the time is what is your title, what are the predictor labels, and what's your dependent variable label. So if we come back to R, we can say tab model, and then our title is table 3, predicting income. And we'll just say db, is it db.label? Yep, equals, we want that capitalized. So now we have that information. And what is nice is, since our gender variables and certain variables were factors, they will specify what they are referencing. So what that means, in going up, it looks like the female gender is our intercept, or our reference group. And this is on that gender binary. So we can see what is a significant predictor. It looks like the more Transformers movies you watch, the lower your income will be. Um, if you believe in ghosts, it's not as big of a difference, big of a drop as if you don't believe in ghosts. Um, and then some non-significant urinating in the shower. Um, but what we are also really interested in is writing this up. So if we want to actually include this and we're writing an article, we want to have our values update in reference to if we change the model or we take out items, because that is can always be a pain. Um, what I've shown folks in the past is in the easy stats package under report. This is actually in the report library, but you can actually ask for a report of your analyses. So you use report, and down here it will give you a rundown of what each of these mean. Very basically, so it will go through in semi-APA format. It will walk through what all of these findings mean. Not specifically, but just are they significant? What does this mean? What does this mean? So we are able to take a look at all of those. And this just can be really helpful to just make sure that you're thinking about things appropriately. It's just a good check, but I wouldn't encourage students to just copy these findings. Um, what we really want to do is pull in our findings. We want to be able to write in text what these mean. So what we can do here is you can start typing outside of the code chunk. We ran a linear regression model to predict income and found that, let's see, the number of Transformers movies significantly predicted um, a lower income. And then we can put in our values. So I'm just going to use the unstandardized, but to then call specific items, we first need to see where is this being saved? Where is this information happening? Um, so we can look here in model 1 where it is under coefficients. So we can see model. There are different ways. We'll start with the very basic, and then if we have time, go into something that's a little bit more straightforward. If I do model 1, $ coefficients, it's going to give me a table of the coefficients. It'll give me all of that information. So it'll say what the intercept is, age, gender. So then if we ask for the specific coefficient, we'll be able to, I believe it is, nope, it is a vector. So if we take a look at that, I'm just going to assign it so that I can see a little bit more what it is. Sorry, just need to close that so it's a little bit easier. We can see that it is just a string of values that is named numerically 1 to 9. We know that our transformers variable is 1, 2, 3, 4, 5, 6, 7. We should then be able to look at item 7 and name that to coefficients again. But what we can do is once you have the specific numerical value, to put it in text, you use the backtick, which is right under the escape key in the top left. You say that you are using R, and that you then type in whatever your R code is. So we're going to say model 1, $ coefficients, and then 7. And when you can highlight this and hit Control Enter, and it will say that it is null, which doesn't make any sense. Make sure that I have that down correctly. So now when we are going to knit that document, I'm going to come up here to knit again. And let's see, it'll take just a second because now we added a couple new things. And I will open up the HTML file one more time. We'll scroll down. After visualizing, you can see that it gives our output for our regression. Here is our nice looking table. There's the report. And here is that line of text that we had. So it inputs the exact numerical value here for our beta weight. This will update if we do change. You'll notice that it is too many decimal places, so we can round that here. If we just say round that number to the second decimal place, just 2, we run that, it will only include that. The one other function that can be really helpful in these instances is using the broom function. So this is one way to basically take all of the parameters and put it into a nice table that is easier to reference. We would use the tidy function. And now it includes all of the estimates, our standard error, the test statistic, and the p-value, all in a single table. So then you can work with it a little bit easier. You can then use dplyr and update the specific information. So let's work with that, because I will put let's see what happens if we use this function that we just had in calling the specific coefficient and indicating which number in that vector it is, versus using broom or tidy, how that can update a little bit more dynamically. So up here, we're going to use this type of a function to select the transformers variable. I am going to create a variable called transformers, beta, and because it has created a tibble here, we can then use functions to select and filter the specific variable that we want. I want the term to be transformers. and it does need a double equals. That was my fault. And then we just want to select the estimate. And that will give us one observation of one variable, which is that. So what this will do is it creates the table, and then it will search for our transformers variable, and then it will provide the estimate. So if we then want to call just this item down here in our beta function, I'm going to delete all of that. So we still have now our backtick R to get to then say, look at this variable. So when we run this, it will give us the same exact value. We can round that as well. Just keep it unrounded. So the reason why you might want to have something that is more dynamic, where you can look up the specific variable or the item rather than just referring to a column, is maybe we realize that this shower P variable doesn't work, or we don't care about age in this case. So let's take out age and shower P. If we then run all of this again, we won't be able to find this value here, because now our model coefficients do not have 7 items. There is no 7th variable. But if we look here to our transformers variable, we're able to pull that in because it is searching for the specific item, that then you're able to call for that. So if we were to knit this document and take a look there at what it looks like, this will then only show a value for our sample 2 item. As you can see here. And it does not show anything then for our NA variable. So those are some ways that you can start working with and using R to take information, report it in text, and then have it knitted to a document either in HTML or PDF or Word. Finally, what I wanted to show folks as we start wrapping up, and then we'll have some time for any questions if you have them, is using the Papaya package or the articles package. So I am just installing Papaya and then install.packages. And then the articles. So these are some packages that are designed to update and give you some more templates for knitting documents. Now, if we were to come up to our document page and go to our notebook, now you'll see that there is a from template section that we might not have had before. You can then see here in the from template that there are APA style manuscripts. In the articles package, they actually have specific journal article styles. So if there are specific styles that you want to publish within, like statistical software, that this will, or Applause One Journal or PNAS, you can do that very easily. But let's just go to APA style manuscript. And now there is a link that I have to Papaya in the in our section here. But this will walk through. You can see that it is a little bit more complex in the beginning, where you're walking through what's the title, who's the first author, what are the affiliations. It actually walks through your abstract, creates any author notes. You can import your bibliography if you do have that in usually Zotero or Mendeley. You can just export your .bib file and pull that in, and then it will update and put in all of your references, and you can use those in text and everything. But here you can start pulling in the information just like we were doing before with the backtick R. If we go ahead and try to knit this, it's going to ask me where I want to save it because I did not save the document just yet. It's likely not going to work, or no, because the references.bib file is already in there. So let's see. I have to update TinyTech. But while I am doing this, with the last little bit, do folks have any other final questions or comments, or things that they wanted to just check in about? Yeah, go for it. You can ask away,
Yeah.
Jasmine.
So thank you very much for your clear presentation. I think I have more of a general question. So I have used Markdown a couple of times before, but I have never used Quarto. So I would like to ask, which one would you recommend?
Definitely. There is a movement, I think, in the field that folks are trying to integrate more of the Quarto documents. Um, and really, I think they're a little bit more versatile. You can use different functionality, or I think they integrate better or are more compatible across different, like RStudio versus Posit. I think they do, and some other things. I think Quarto is just more of a data science-y kind of piece. I've been trying to use Quarto documents a little bit more. They are basically, in my experience, identical. So there hasn't really been anything that I have seen that has caused any difficulty in transitioning from one to the other. So that's just been my experience. I'm sure there are nuances in actually using them, or maybe some are more efficient or less efficient, but that's been my experience so far with Quarto.
Okay, thank you very much.
Yeah, other thoughts or questions or feedback that folks have while my computer tries to figure out what Papaya is doing?
Can I, like, in the meantime, ask another question?
Of course, yes, that's what this is for.
Yeah, a short question. So is your Markdown file somewhere available? Because I think that's like would be really nice to have.
Yes, so the initial template is there in the chat on OSF, and I will update it with what we've worked on today so that anything that I've done will be on OSF as well.
Cool, thank you very much.
Definitely. It's really thinking hard. We might never be able to see what happens with this Papaya document. I haven't I've only written some result sections in R. I haven't actually used the full Papaya package before. I've always said that I wanted to, but one of the things that has been a challenge for me is whenever you are um, collaborating with others and they want to give you feedback, I've found it challenging to integrate that into then putting it back into my document and then exporting so I can get comments and feedback. And then it just gets rather complicated, especially if it's really nice if everyone is using GitHub or any other sort of like version control with the text. But a lot of my colleagues tend to use Word and are not familiar with using GitHub. So it makes it challenging to work with, and I just haven't been able to integrate those things just yet. Um, but it looks like some of my repositories aren't working, and rather than me trying to figure it out with the last few minutes, um, we can either end early or I'll stick around until the end, but feel free to reach out to me with any other questions. My email is here. I'm always happy to talk about R. And if there are other things that you wanted to talk about, feel free to send me an email. I'm more than happy to discuss. But thank you all for joining. Like I said, I'll stick around for another couple minutes. I will end the recording so that we're all set.